Thanks for watching. We're back. That's the last thing I said, so I thought I'd say it again. So negative 3 plus 2 is negative 1. So we got that to the other side. Now, how do you get tangent over the other side? Well, this is a 1 tangent theta plus pi over 3. This is a 2 tangent theta plus pi over 3. So can't we just go ahead and minus that 1 tangent theta? Oh. Wow. So much to write. So can we go ahead and minus it to the other side? Because it's just a big thing, doohickey, right? Yeah, just like minusing x to the other side. So we're going to go ahead and minus that to the other side. So now 2 minus 1 is tangent theta. Showing all my work. Okay. So yep, so 2 minus 1 is just 1. So now we have negative 1 is equal to 2 minus 1 is just 1. Tangent theta plus pi over 3. Beautiful. So now we're just going to solve for just tangent theta right now, and we're going to minus pi over 3 at the end. Okay, so now we have tangent theta is equal to negative 1. Now, what can make a negative 1 with a tangent? Well, tangent comes from sine over cosine. Cool. So we need sine to be something and cosine to equal something to equal negative 1. Well, think about the unit circle. That something over something has to be the same, right? Because anything divided by itself is 1. So what can you see? What coordinate can you see that's the same? What coordinate can you see? I'll show you what I mean. So is this the same? Radical 3 over 2 1/2? No. Is this the same? Radical 2 over 2? Yes, it is. Radical 2 over 2. And that divided by itself is just 1. But we do want a negative 1. So we're probably looking for this guy. So negative radical 2 over 2 divided by radical 2 over 2. So that should give us a negative 1 there, right? Because we want a negative 1. So there we go. So we have negative radical 2 over 2 all over positive radical 2 over 2. And so that's going to give us that negative 1 there when you put them together. And so where does tangent equal negative 1? Well, at the coordinate where we have negative radical 2 over 2, comma, radical 2 over 2. And so that's going to be in 2 places. That's going to be at 7 pi over 4. And then where else is it going to be? Negative radical 2 over 2 over radical 2 over 2. 3 pi over 4. Nice. So we have 3 pi over 4 we're going to use. Memorize it. So I'm going to ask you in a second. And 7 pi over 4. So 7 and 3 pi over 4. Nice. So 7 and 3 pi over 4. So there's our 2 answers. So 7 pi over 3. What's the other one? New bold. Sorry. 7 pi over 4 and 3 pi over 4. Right? Was I right or was I wrong? I hope I was right. Okay, so then, so now we're going to deal with this sucker. We're going to have to go to minus pi over 3. And then minus pi over 3. So now we've got to get a common denominator. Do you remember how to do that? I'm just double checking. Yep, 3 pi over 4 and 7 pi over 4. Just checking. Check yourself before you wreck yourself. Okay, so we're looking at number 21 right now. Cool, so we got to get a common denominator. Denominator. What? I don't know. Sounded good. Okay. Denominator. Okay, so 3 and 4. How do we get a common denominator there? Well, 3 can't go into 8, but 4 can. What about 12? 12! 3 times 4 is 12. 12 will work. So if we do 3 times 4 and 3 times 7 pi, and then over here we're going to do 4 times 3 is 12, so we're going to multiply a 4 up there. Then we get 3 times 7 is 21 pi. Good. All over 3 times 4 is 12 minus 4 times pi is 4 pi. And then 4 times 3 is 12. And now we have a common denominator. So 21 minus 4 is 19, 18, 17, 16? No, 17. Yeah. 17, 18, 19, 20. Good. So we have 17 pi over 12. Phew. There's our answer. What a crazy answer. So there's one of our answers for 21. And then do the same thing. Get a common denominator by timesing by each other. So if it's a 4, times it by 3. If it's a 3, times it by 4. And now we get 3 times 3 is 9 pi over 12 minus, and then minus 4 pi over 12. And 9 minus 4 is 5 pi over 12. Excellent. So that is for number 21. So that's for number 21. Wow, oh, that's it. 5 pi over 12, 17 pi over 12. We got it. So there's number 21 to help you. Last one, 27. Helping you on a lot of these. Hey, look. Cambry. Go get Bailey. There's the artwork. It's on my video even. I didn't just show it in class. It's on the artwork. It's on my video. Bailey, you're immortalized. Pause it. Go get Cambry. Go get Bailey. Did she like it? Did you love it, Bailey? Did you love it? I know you love it because that was amazing artwork by Bailey Ross. Remember Bob Ross? That's right, Bailey Ross. Hey, is that a heart? That's cute. I just noticed that. Okay, so we're jumping to number 27 to finish off this video. Okay, so number 27. Ooh, pretty. So we have a 1 tangent, and over here's a 4 tangent. So let's go to minus that 1 tangent over to the other side, right? Get it over to the other side. And so that'll take it down to 4 minus 1. And so 4 minus 1 is 3 tangent theta. And then we're going to go to minus 1 over to this side. And so negative 2 with the negative 1 is a negative 3. Because we minus the 1 over to that side. Good. What the? Oh, phew. So we still have the 3 tangent there. And we're going to divide by 3, divide by 3. So now that's going to give us a negative 1. And now we just need to find where tangent theta, I feel like we already did this, gives us negative 1. So we're used to thinking about it in terms of radical 2 over 2, which is important, divided by radical 2 over 2. But now our multiple choice answers are going to go ahead and give us, we got to find the degrees that are related to that radical 2 over 2. So remember, sine's on top for tangent. It goes sine over cosine. So we're looking where sine is negative radical 2 over 2 and cosine is radical 2 over 2, and then switching them. So go to the unit circle. Can you find it? Come on, you find it. Come on. So negative radical 2 over 2. Yep, here's one of them. So we're going to use 135 degrees as one of our answers. And where's the other one? Is it down here? You know it is. We use this one so many times on this assignment. And so that's 315. So we're going to use 315 and 135. Sick. So 315 and 135 is what we're looking for. Can you find that? So we have 315 and 135. Nice. Why is it in every answer? Because they're extra stuff, maybe, I guess? Yeah, so 27 is D. 27, right? So let's double check there. Yep, 27 is D. Sick. Awesome. We helped you out there. So thanks for watching. So go ahead and try 28 and 26 and 25, multiple choice options. Again, we went ahead and found we used the unit circle, and we tried to find where radical 2, negative and positive are. That's these 45-degree angles, right? Negative radical 2 over 2 and positive radical 2 over 2. And then down here was the opposite of that. It was over radical 2 over 2 for cosine, and then negative radical 2 over 2 for sine. And so that was our 315-degree angle associated there, because that goes all the way around 315. And then also just to there was our 135 degrees. Cool. And so that's where tangent of theta equals negative 1. Cool. So thanks for watching. Thank you. Keep on busting through this assignment, and be ready for the next one. Watch all my videos. You're the best. Subscribe. Hit that subscribe button. They all say that, don't they? Why did they say that? Because they want a ton of views and get money. I just want to help you. So subscribe. Oh, just so you can watch my videos. Thanks, guys. Peace out. Thanks for watching. Bye-bye.